Hi everyone, welcome to the peer graded assignment for the course project, Machine Learning Foundation for Product Managers by Duke University. This is Anush Sharma and I'll be presenting the step-by-step process that I've used. The score guidelines that are laid by the project is as follows: that will be judged on the modeling approach, model building, model evaluation, and model interpretation. The summary, the project topic is here we are provided with some data set for a combined cycle power plant, which use a combination of gas turbine, steam turbine, and heat recovery generators to generate power. We have a set of 9568 hourly ambient environmental readings from sensor at a power plant, which we use in our model. The data that is provided is as follows. I've segmented the data into training set and validation set. We'll be using the training set to generate the coefficients and use that on our validation data set and then compare the models. We are using two model here. Model one would be with four features. Looking at the coefficients, we'll be dropping one of the feature with the least coefficient and then create another model with three features. I'll move to model building. Just a quick highlight, we have segmented the data into two parts, which I've covered earlier. The percentage allocation is clearly defined, and then data row counter is as mentioned. We are using two metric here to compare the model accuracy. One is MSE, which is mean squared error, and second is R square. Um, as mentioned in the data set, we have clearly highlighted each rows as training set and data set to safeguard ourselves from data leakages so that same data point is not used in both training set and data set. Um, we are using a linear regression model. It is a simple first model to benchmark. Second, there is very clear correlation between the input and output. Here, in the first model, we're using all four variables. The P is that is provided. We have also predicted the P using the Excel regression model. The R square, the multiple R and the R square is also provided by the same. We have just tried to use correlation and validate that the data that is being used in the model is correct. So the R square that is coming from the model and R square that we have calculated are identical. If you see at the coefficients, the coefficient AP has the lowest absolute value, and that is why in our second model we have dropped AP, and we'll be using remaining three variable following the same process. And we have predicted the P, and that has also given us some coefficient that we'll be using on the validation set and then comparing both the models. Now, on our test set, uh, we are using, so what we've done is we have captured both model 1 and model 2 coefficients and used it to generate, we have used it to predict the P both for both the models. We have also calculated the error square so that we can actually use it to generate the R square and mean squared error. Now the R square that was that is generated using the correlation formula for both the models are captured over here. Here we can clearly see that R square is marginally better for model 1 and mean squared error is also marginally better for model 1. So we would like to pick model 1 for our computation. Now, depending upon the objective, we can actually opt for both model 1 and model 2 since there is very marginal improvement in model 1. So if we want to optimize on the computation standpoint, we might opt for model 2, where we'll be using only three variables to generate the output. If we want to optimize for error and reduce the error, then we'll go with model 1, where the output is marginally better. Thank you.